Good afternoon, everyone. So this is a quote, not from any great man. This is something from my own experience and the architects who share the same mind share, right? Like modernization is not the end state, it is beginning of the next stage, right? And this particular quote, right, it is based on the experiences that I have got since I joined the industry almost 24 years back, right? I started with mainframes, then did Oracle, PL SQL, did Java coding, did Hadoop, Android, data warehousing. Right now I'm working on microservices and also building some data platforms using Snowflake and all, right? Now, why I put this quote is because whatever I say today, right, that is not the end of it, right? So something new will come in. So that's as an architect, I believe that the architecture that we develop, right, we should think of that architecture not as a non-living object. It's a living object, and it should evolve, right? It should evolve based on the new innovations that comes into the technology world, right? Unfortunately, we have been building applications in a very rigid monolith way. That application architecture needs to change to more of like a product architecture. I'll give you a recent example. So I was building this data ingestion and analytics framework for a bank. And the initial requirement was to get the data from AWS S3, put it into a Parquet file on S3. But what happens if tomorrow there is a better storage engine, there is a better storage output? How do I do that, right? So what we did is we created a framework. We had a data writer factory, we had a data reader factory, so that if tomorrow I decide it's not S3, I need to put something on Snowflake or something better that will come in, I don't have to change anything in the code, right? So what are the key drivers of modernization that I have been seeing, and then I think it will resonate with you also, right? What I see is the key driver is to get the data and the business features or the business logic faster in the business applications, faster to the consumers of the data or the business, right? So business agility is one of the most important factors of the modernization. I see a lot of the organizations are kicking off modernization or data modernization engagements to meet the data security requirements. As I speak, for many of our customers, we have kicked off a data disposal program, like because there is a data compliance rule that has come up, which is called CCPA, California Consumer Privacy Act, right, which is similar to the European GDPR requirements. But that's just one example. We are also building some purge archival or data to manage the data lifecycle, building some applications to meet the requirements of data privacy. And last but not the least, cost optimization, right? Moving from a proprietary product to an open source product, right? That also I'm seeing a lot to reduce the cost. And in this third category, open source has made us bold enough to take such decisions, right? In many places, we are replacing proprietary products with custom-built open source based application. And I'm sure like maybe 7, 8 years back, nobody would have taken or nobody would have been so bold to take such steps. But now we are able to do this because when I look at the open source world, there are a lot of components, very mature components like Spark, like Kafka. I was looking for a parser, data parser, because one of the data ingestion, I was able to find a lot of these mature open source products that I can put together and create something that is almost similar to a proprietary product. A lot of organizations are moving out of these proprietary products and building their own custom developed products, which is their system of differentiation, right? So the next I'll come, what are those systems that we are modernizing? System of engagement, that is the face of the organization. That is where the highest level of changes are happening. The pace of change is very fast, right? System of differentiation is the next one, where the example that I was giving you, right, moving from a proprietary product to a custom built product, because organizations want to embed the organization experience, organization best practices in those system of differentiation and take it to the customers and say, this is our differentiation. When I give you a recommendation that you buy this stock or you trade in this, right, that is based on a product or based on a system that we have built, which is the intelligence or the experience of the organization, right? System of records is where I see a very cautious approach. People are still a little scared to touch the system of records, right? So there the pace of change is slow, but there are patterns there as well. Because I still need that system of record which is in the mainframe DB2, which is not very easily accessible outside mainframe. I still need that. So the one pattern I have seen is offloading that data for the new world to access. So your system of records still remains in the legacy, but now have a system of reference which the new world or the new architecture will use, the digital applications will use. And there are multiple ways you can get it. So we have done it using Kafka, using MQ, using various change data capture products and all, right? And it's a very successful pattern. There are some organizations where I have seen that they were bold enough to move the entire system of records to some of the new age databases, right? But that percentage is very small. My session was named as Living Legacy. That was actually not right, right? How many of you believe that mainframe will not exist in another 5 years? Or legacy will not exist in another 5 years? No takers? Good. I expected that. I started hearing mainframe, get rid of mainframe when I joined the industry, right? Maybe my parents also heard the same when they were just towards the end of their service, right? But still mainframes are there. So legacy or mainframes are not, my belief, are not going to go away, at least in my lifetime, right? I don't know what will happen when my daughter will grow up, right? But in my lifetime, I'm not seeing legacy and mainframe is going away. They are going to stay. There are a lot of innovations happening in the mainframe world also, right? So optimization or modernization will need to happen both in the legacy world as well as the new world, right? And moving out of legacy should not be a big bang approach. It should be thought through. It should be a gradual movement or gradual transformation to the new world of microservices architecture. And I'm going to talk a lot about that when I talk about the integration pattern in the slides that will come off after this slide, right? So the other thing that I actually wanted to highlight in this slide, any modernization, if you retrospect, right, whatever you are working on, what is driving the modernization? What I see is data. Data is driving the modernization. But when you start modernizing the data, like when you try to get the data quickly, get the data ingested quickly, consumed in a better way, you also touch the application, and finally you also touch the platform on which the applications are deployed, right? So that's one thing I wanted to highlight here. Now, there should be combination of strategies. Combinations, there are non-invasive strategy, there are invasive strategy. And this slide is self-contained in a way, like it talks about in which cases you should go for a invasive strategy versus a non-invasive strategy. But nonetheless, any organization will have to have a combination of invasive and non-invasive strategies to modernize their existing landscape. The different techniques of modernization, rehosting, I think we are very familiar with this one, where we rehost mainframe to a x86 architecture. Refactoring, where we try to refactor the existing code, try to optimize it. Integration, that is what I'm going to talk more about today. This is a very popular technique, and this is the technique which helps legacy and the contemporary to coexist and then transform, right? And some of the invasive techniques are reengineering, package implementation, where you take a complete process running on legacy and replace it with a mature proprietary package, right? And migration. So integration, that is the technique that is very much in use now. It is very popular. And how you do it is, if a function or a business process is running in legacy, you wrap that module, servicify it, right? And then renew it, and any underlying business flow, workflow that is there, you abstract it. The business rules, you abstract it and bring it outside of the system. If I show you the next picture, it will be more clear, right? So we start with a monolith. It may be by the way, mainframe is not the only legacy monolith. There are Oracle applications, there are Java applications which are monolith, which are legacy, right? Those also needs modernization. But the approach for this integration technique is similar, right? Where you servicify the monolith. That is the first step, right? Now, for the mainframe, we use products like ZOS Connect type of or Kix CICS gateway to API-Fi. In one of the engagements, there is an interesting approach we have taken. We are writing DB2 procedures, and whatever logic is there in the CICS COBOL, that logic we are pushing into the DB2 procedure, and that is exposed as an API for the API gateway to consume, right? So once you servicify the monolith, the next thing is to create a strangler facade. You might be hearing a lot of terms for this, right? But ultimately, it is a strangler. Like people will be still telling that it's a particle layer. Some people says it's a speed layer, and then there is some people will say that's as an anti-corruption layer, right? These are more marketing type of terms, but technically, it is a layer that helps you strangle the monolith and decompose into services gradually. There is one more myth in this technique, that I need to completely move out of monolith. That is absolutely not required. You need to do a cost-benefit analysis. Sometimes I will stop at the third step, like where transform and coexist, because breaking the monolith further into microservices does not give me any substantial business benefit, right? So I don't need to completely move out of legacy, right? That's where I can decide to either coexist and transform or completely move out as well, right? We are following this approach for many of our engagements. One of the One of the engagement is with an utility company, right, where they have a Monolith, Oracle and .NET based utility platform. It uses Oracle, AQ. So they recently acquired another company, and when those customers will also come to that platform, what they have seen is that the platform with its current set of consumers only is not able to scale, not able to meet the requirements of the load and the scale, right? So if another 3 or 4 million customers on board, then it is going to go down. So we started modernizing it following the same approach, right, where we are using Spring Boot, Apache Camel for orchestration and Kafka for choreography. We are taking one service at a time, moving to the microservices based architecture. There is an API gateway. When the request comes for a particular API, the API gateway, it then routes it based on like where the service is lying right now. Is it still in legacy or in the services, right? That is the pattern that we are taking. But one thing to be careful when we follow this technique is, so while we are doing that architecture for that utility company, there was a ask that when I move a particular service to microservices, I need to have a bidirectional data updates between the legacy or the old functionality and the new functionality. Both should update the data. So I say no, and this is and why. When you move a service to the new world, the stewardship of that particular domain that it manages needs to reside with only one owner. Multiple owners, if you try to have multiple owners update and write the data, you will have a lot of problems. And this is, I'm telling you from experience. We have done this in one place, and then we kept on creating data synchronization, and it's a vicious circle. So when you move out, the domain along with the service, the stewardship of that domain should lie with a single owner. And finally, we did that. The data can be read, right? You can still move the data like using CDC and all to the old world for the downstream to take care, but only for read, not to update the data. One of the other most important activity when you move to microservices based architecture is to identify the services, identify your domain boundaries. There does not exist a magic wand which will tell you, okay, these are the services that you go and build it, right? We are trying some approaches, which is a bottom-up approach by looking at the code, looking at the database, looking at the transactions, using some AI ML mechanics. Can I identify the services? So far, we have not been successful yet, but I hope maybe 1 year down the line, we'll see some success. But as of now, how this approach happens, it's a top-down approach. You take the business standards. There are some business specification. For example, for financial services, Beyond is a standard. Like if you want to create a payment service, the Beyond tells you how to create. Like there are some specifications that they mandate. So you take that specification, you take the reference business architecture, and there will be brainstorming sessions or event storming with your business to come up with the list of services or the catalog of services that you need to build, right? The output of this exercise should be a capability map. And this is what we are trying. As I speak, we are trying to see if we can automate that. So far, the domain definition and the process definitions, we are able to extract using some automated way, but that would be like less 10 to 20% of the success, right? And so ideally, process capability is nothing but a group of similar process definitions that you bundle together, and that is exposed as an API to your business. That is what means as the domain of that particular service, right? And a process definition may encompass one or more domain models. So this is what I am showing you right now. That is for a core banking application. We have similar capability models for retail industry, for manufacturing industry, for energy industry. The approach is same, only the capabilities, the domains, and the processes change. How the reference architecture look like? So in the target reference architecture, the API layer plays a very important or a key role. If you think of this as a nervous system, right, human nervous, I like to see architectures like a human body, right. So if you think this is a nervous system, the API is the eye and the brain. At the bottom layer, you have the system APIs, right, which are stateless transactions, which are the data APIs, right. Your domain objects are exposed through those APIs. And then in the process layer, you have the process APIs. The process APIs should not know how the data is structured or how the data is designed. Tomorrow, I might want to use a completely different data structure or a completely different database, but for that, I should not have to touch the process layer, right? That is what, so that part is being extracted by the system APIs. So once your process layer is developed, your process APIs, on top of it, you build your experience APIs. So if you think of this thing, right, it's an inverted funnel, right? You have all of your data, then the process takes the data, and finally, in the experience layer is where you do further filtering, further aggregation, and give that data like the consumption model for the consumer, right? Because your data may be consumed internally or by a partner, but the way an internal employee consumes the data may be different, like a partner consumes the data. The data attributes, the data fields may be different, and that is where you do in the experience API. So the external API, so there is an API management layer externally and internally. The external API management layer should take care of your throttling. If somebody wants to do a DDoS attack and all, right, that should capture it, the authentication, right. So that external, when there is an external request, right, if it is a malicious request, it should be stopped at that API layer itself. It should not go inside, right. So a lot of people ask me why I need to have it outside the DMZ. That's why, because I don't want anybody to enter, a malicious activity to enter internally, right. So that API layer is the external layer. And then you need to have an internal API layer also, because I need to drive a lot of analytics out of this data, right? Who is using the API? And if tomorrow I want to monetize some of these APIs, this is what will drive this monetization. That is why when you select an architecture like this, selecting the API product also becomes very important. There are a lot of products available, but none of the products are good or bad. It depends on what your architecture needs. That is why you need to do a product evaluation and choose what is the right product for my architecture based on what I need. So the next section is where I'm going to demonstrate you a platform that we have built, right? And before I show you the demo, I want to go through some slides will tell you why we built that platform. So far we have seen modernization, the strategies, and then the integration technique and all, right? But it is not easy to implement or deploy or design that particular architecture, right? There are a lot of challenges. The first one is there is a range of technology product. There is a range of architectural patterns. Do I use a event-driven architecture? Do I use a microservices-based architecture? Within the event-driven architecture, what should I choose? Should I use event sourcing, event notification, state-carried event transfer, right? So one complexity is to choose the architecture. Once you choose the architecture, the next complexity is Now I know like it's a microservices based architecture. Now what do I choose for the API layer? What do I choose for the database layer? As of today, there are more than 300 varieties of databases, NoSQL databases or RDBMS that are available in the technology space. And every database has its utility. It depends on what use case you are trying to solve. We are actually implementing CockroachDB. I'm not sure how many of you heard about CockroachDB. Good. So we are implementing CockroachDB to take care of a use case of distributed SQL and distributed aggregation. My applications can be on-prem, can be on AWS, Azure, GCP. But when I query, the database should be able to do a distributed query, aggregate, and give me the data quickly, right? So every type of database or every type of product has its own utility. It depends on what use cases. So the complexity of this is, what should I use? Is Cassandra good? Well, Cassandra is ring structure, highly available, but it is also an MVCC. There is a write amplitude that might happen. Is my application doing a lot of updates? Then probably I'll choose something else, right? And then the people who can actually make those choices. Any good things are limited in resource, right? Similarly, architects who can make such decisions are very scanty, not abundance, right? And there is a complex vendor ecosystem, and this is a struggle. This is something that our clients are struggling with. So in any modernization program, you will see there are more than one product vendor. In the mix, you'll see a database, you'll see an integration product, you'll see an API product, you'll see a microservices product, you'll see a microservices platform, then there is the cloud part of it, right? So we recently did a survey, and we said in any modernization there is at least 8 vendors involved, and negotiating with all those 8 vendors, doing creating a contract, right, for using or getting the subscription and all, right? It's a very cumbersome process. It's a time taking process and all, right? And then to actually start the project, right, you need to do an environment provisioning, software provisioning, get the environments in place, right? That takes a lot of time. That is where we built this suite of services plus a platform called Infosys Modernization Platform, right? The comprehensive professional services is like in our practice, we have around, so it's a 300 member architect team. Out of them, architects who can actually do this type of work will be around 150 to 175, not even 200, right? So we have this, architects can go in and then select the architecture based on the requirement and do a product assessment. We have some consulting kit to do that, to do those product assessments and all. Infosys Modernization Platform, I'll show you a demo of that. The single commercial interface with all our strategic partners. Kong is one of our strategic partners. We have a agreement that along with the services, right, we can take the subscriptions also along with it. So for the client, it's a single neck to choke, right? Only Infosys is visible to the client, not the other vendors. Single support interface, right? L1 support, L2 support, right? Infosys is the face. For L3 support, we interact with our partners. Client does not have to interact with a lot of these partners. And lastly, we have a limited set of full stack agile developers, right? We call them power programmers, right? We bring them along for the initial POC or a pilot, right? So the pilot or POC can be done very quickly, right? Now let's take a look at the Infosys Modernization Platform. So this platform has 3 roles. One is the architect role, then is the developer role. Oops. Oh, since I stopped it, I think that's why, is it? So while it's coming, this platform has 3 roles: the architect role, the developer role, and a platform admin role. When the architect logs on to the platform, he chooses the architecture, chooses the products in each layer, and provisions the environment, the application. The developer comes in and then spins up a local environment based on that architecture that has been chosen. Thank you. And finally, the platform admin is a person who does the metering and monitoring, because if this is, let's say, on cloud, right? And I'm using some managed services on the cloud. How much have I used for MongoDB? How much have I used for Kong? Or how much have I used for OpenShift? Right? That's metering and monitoring is done by the platform admin. So let me start the video. This is the architect role. He can do all these things. So that was when it selected the architecture. Now it's a opinionated stack with choices. What we did not want to have all the products available to be put in the platform, right? Each layer, we selected the leading 2 or 3 products in the market. In the API layer, we have 3Scale, we have Kong, and we have WSO2. These are the only 3 choices then you can make when you need to choose a API product using this platform. Similarly, we have a choice for the databases. So it's an opinionated stack with choices. Even the DevOps CI/CD pipeline is an opinionated pipeline that comes along with the platform. And we do not allow to modify some things in the platform, because then you will not be able to control it. So for the developer, when he creates the environment, it also creates some boilerplate code. For example, tracing, right? It does not have any business logic, service tracing and all. So those type of code are auto-generated by this platform. So this is the build pipeline. So once he commits the code to the source control, the platform admin manages the software subscriptions. So these are some of the dashboards for monitoring the environment as well as applications are available in the platform. So I think, yeah, this is the end of the demo. Now I want to leave. That was the last thing that I wanted to show you. In fact, there are some migration toolkits for which I don't have any demo as of now. So a lot of this database migrations, application server migrations, we have tools developed for those. Those are also embedded in that platform. I want to leave you with a thought, right? Can you all retire after you move to the distributed microservices architecture, right? Serverless computing is actually developing in a pace faster than we think, right? It is not mature yet, but it is getting mature, right? So what I wanted to tell is, like, we can't retire after we move everything in the microservices architecture. There is something else that is coming up, which may be better or more efficient than what we are building now. And that's all I had to tell today. Thank you.